Okay, hi guys, it's Miss Kate's. It's our second to last video, so we're almost done. I'm going to try to go through this one quickly because I know you're not loving watching these. This is our Unit 6 review on trig. So the first thing that we're going to talk about is the Pythagorean theorem. And we've gone through this many times, so I'm just going to quickly go through the formula one more time. So just so you remember, we have a squared plus b squared equals c squared. And the most important thing to remember, whoops, let me just move that, is that C is always the hypotenuse. Okay? So in this example, if I'm solving for C squared, I'm just going to go ahead and plug in. So I'm going to plug in 6 squared plus 8 squared, set it equal to C squared. Let me just go ahead and move my formula over. And then I get 36 plus 64 equals C squared, and 100 when I add them equals C squared. And then the last step, which a lot of you guys forget to do, is you have to take the square root to solve for C. So you would get 10 is equal to C. So that's really all we need to go over for the Pythagorean theorem. All right. Next thing for trig we went over was sine, cosine, and tangent. This gives you the formulas, which remember you will be given on the final exam. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And remember, we must label our triangle. So here's an example. It says that in triangle MCT, the measure of the angle T is 90. Okay, so the first thing I'm going to do is just make sure where I have MC, I'm going to make sure T is my 90-degree angle. Then it says MC is 85, so I'm going to label that. CT is 84, and TM is 13. And all they want to know here is the ratio of the sine of C. So remember, we hit our angle that we're referencing, and now I can label my triangle. So opposite is always across from the angle. Hypotenuse is the line that's across from our 90-degree angle. And then this leaves us with the adjacent. Remember, the adjacent side always shares a side with the angle. And then sine is equal to opposite over hypotenuse. So I'm going to circle my opposite. Here's my hypotenuse. So it's got to be 13 over 85, which is choice 1. So it's really just, thing is to remember is to make your diagram, label all your sides. All right, the other thing we went over is how to find the length of a side. And this is where we use sine, cosine, or tangent. So again, in this case, I'm just going to make my right triangle. And they tell us that the hypotenuse is AB. So I'm going to make this A, this B, which makes C my 90-degree angle. I'm going to just hit that. AB is 15. And then they tell us that angle A is 35 degrees. And they want us to find the length of BC. So I'm going to call that X. So again, the first thing I'm going to do is label my triangle based on angle A. So it's all based on this angle. Well, we know 15 is the hypotenuse because they tell us that. X is going to be the opposite side. And then here's our adjacent. Now, we don't know anything about the adjacent side, so I'm going to go ahead and almost ignore it. And I'm going to circle opposite and hypotenuse. So I'm going to therefore use sine. So I can set this up saying the sine of 35 degrees is equal to opposite, which is X, over 15. Okay, I'm just going to scroll down for a second. Let me just move this whole thing down. Oops. All right, so the easiest thing here to do is when you see these is to just put it over 1, because now what I'm going to do is I'm going to actually cross multiply to solve for X. Because again, we're looking for that opposite side length. So they tell us the sine of 35, we're going to multiply that by 15, is going to equal X. So now on my calculator, make sure you're in degree mode. which I'm going to do right now. I'm going to find the sine of 15 degrees. I'm sorry, the sine of 35, which is 0.5735. That times 15 is going to give me x. So when I multiply that by 15, I get 8.6. And I think they said to the nearest tenth. Let's just scroll up, double check. Yeah, nearest tenth. So 8.6 is my final answer. All right, now the other thing that we did discuss is solving for an angle. So I think the key thing here to remember is that when you're solving for an angle, we have to use the inverse functions. So I'm going to go ahead and set up the triangle just like I would if we were solving for a side, and then the end part's going to be a little bit different. So here we have a right triangle. It says leg BC and leg AC. So C and B are a leg, and A and C are a leg. So here's my hypotenuse. They tell us that leg BC is 15 and leg AC is 20. And they want us to find the measure of A. So this is my reference angle, X, and I'm going to label my triangle. So here's opposite, here's hypotenuse, here's adjacent. Now I'm just going to circle the sides that they give me information about. That's my opposite and my adjacent. So I'm going to use the tan. The only difference here is that I'm going to use the inverse tan because I'm solving for an angle. So I'm going to say that the tan of A is going to equal opposite, which is 15 over 20. Now here's where I'm going to use my inverse function. I'm going to say the inverse of tan, which is 15 over 20, will give me my angle A. So on the calculator, you just have to hit second tan, and then I'm going to put in the fraction, and I'm going to end up getting 36.9 degrees. And I think they ask it to the whole number, so we would say angle A is equal to 37 degrees. Okay, the key here is just to remember when they ask for an angle, you have to use the inverse. Okay. Word problems. So angle of elevation. Angle of elevation is always the angle formed with the ground. And it's never the right angle, so it always has to be right in that spot every single time. It's never going to be here. Okay, it's always on the ground. Hi, Owen. For everyone who's watching the video, Owen's walking by. Okay, so it's always made with the ground and the hypotenuse. Okay, so let's see what a problem might look like. So it says from a point on the ground 25 feet from the, I think it says base or foot of a tree, the angle of elevation of the top of the tree is 32 degrees. Find to the nearest foot the height of the tree. Okay, I'm going to draw this. So we have a tree. Here's a tree. Okay, here's the feet. And it says that from a point on the ground 25 feet from it. So here's someone standing, and this is 25 feet from where the tree hits the ground. And it creates a 32-degree angle with the ground. And they want us to find the height of this tree. So this is X. So if I make this into a right triangle, we're going to have something that looks like this. This is X, this is 25, and this angle is 32 degrees. So I'm going to go ahead now and solve for X. So I'm solving for the side. So I'm just going to label my triangle based on my 32-degree angle. This would be opposite, and this is adjacent. So we're going to use the tan. So I'm going to say the tan of 32 equals opposite, which is x, over 25. Okay, we're going to put this over a 1 so we can cross multiply. So I'm going to multiply x by 1. So I'm going to get x is equal to the tan of 32 degrees times 25. And when I multiply that out, tan of 32 times 25, I get x is equal to 15.6. And that's it. Okay. All right. Last topic. Let me see what we have here. Yeah. Last quick review is finding the area. Do you remember this? So we need to use a formula to find the area. So when we do not have the information, we would need to use the, okay, basically when we don't have the base or the height, don't worry about the top. But then remember the formula. It's 1/2 AB plus the sine of C. That equals the area. Okay, and I would just write a little star that C is the angle between sides A and C. So let's look at an example. So they want us to find the area of this triangle, round your answer to the nearest tenth. Okay, so this is an example. Here's 25 degrees. This is going to be, we could call this A and we could call this B. It doesn't matter if you switch those up. So I'm going to say that my area, let's call it A, is equal to 1/2 7 times 10 plus the sine of 25. Now I'm going to go ahead and just use my calculator. So I'm going to do 0.5 times 7 times 10, which is 35, plus sine of 25, which is 0.422. And when I add those together, I'm going to get my area to the nearest tenth is 35.4. That's really all there is to it. So you just have to remember the formula, 1/2 A times B, which are the length of the sides, plus the sine of 25. All right, and now let's just try one other. This is asking us to find the area of ABC. So let me see. In triangle ABC, AB is 10, AC is 8, and the measure of A is 40. Oh, I'm sorry, that's another one. We're number 6. I'm reading the wrong thing. Okay, so for number 6, they want us to find the area of the following parallelogram. Now, I just actually wanted to check one other thing before we keep going. So let me just pause this for 1 second. Okay, you guys, I actually realized I made a mistake. This should not say plus. So we just wanted to say times the sine of C. So we're just going to go, let me recalculate this. Sorry about that. So sorry, area is going to be 1/2 times the sine of 35. I realized as I was 25 in this case. Sorry, was not paying full attention. So I'm going to actually go back a slide and just change the formula. My mistake, I had a loss of relapse for a second. Okay, so let's go back one. So the formula, there should be no plus sign. It's all multiplication. I apologize about that. So it's just 1/2 AB times the sine of angle C. All right. So to recalculate the last thing, when you redo it on your calculator, you should get sine of 25. I'm going to multiply it times 0.5 times 7 and times 10. So you're going to get that the area, you should get 14.8. I apologize for that. Okay, so let's look at the parallelogram question before we finish up. All right, last thing. They want us to find the area of the parallelogram. Now, if you look at this parallelogram, I'm going to use the highlighter here for a second. Let me just do this. This triangle makes up half of the parallelogram. And in a parallelogram, these two triangles, this triangle and this triangle, are equivalent. So if I can find the area of this triangle, I can get the area of the entire parallelogram because I could just multiply it by 2. So what I'm going to do here is first I'm going to find the area of triangle ABD. So remember, that's going to be 1/2 times 10 times 16 times the sine of 60. So let me get you that value. So I'm doing sine of 60, and then times 0.5, that's 1/2, times 10, times 16, and that comes to 69.28. Whoops, 69.28. So the entire area of ABCD is going to equal 69.28 times 2, which equals 138.56 units squared. Okay? And that's really it. So just to reiterate, I'm just going to go back to that slide again. Area is 1/2 AB times the sine of C. So just remember, right in there is multiplication. All right, the last thing I want everyone to do is if you watch this video tomorrow when you're completing the packet, at the end of the packet, I want you to put your signature. So just put it on the last page. Just that this way we know you've watched it. Please don't tell any classmates because we really want an honest. So I would just sign it at the end if you watched it, okay? Have a nice night. We'll see you guys tomorrow.